All right, so last time we did exponential graphs. Remember those swoopy graphs? Today I'm going to show you what a logarithm is. Next class we'll do the logarithmic graphs, but first I just want you to get a handle on what a logarithm is. So a logarithm is an inverse of an exponential. And last unit, what we did in unit 5 was inverse functions, so this follows right along with that. So your logarithm is an inverse of an exponential function. So it is a way to solve for an exponent. It's a way to get the exponent by itself. Because, for example, let me just make something up. Give me a number. 3 to the x power equals, and then like say you had the rest of that statement, like you don't have to write this down, I'm just trying to make something up, like x squared minus 2. Like say you had to get x by itself. Like mathematically, there's no way to do that. That's what a logarithm does, all right? It is a way for you to get that exponent by itself, okay? The base cannot be negative. Do you remember us having an involved conversation about that last time? And even if you don't remember why, just go with it. You cannot have a negative base. But does anyone remember why? Remember we made that chart of numbers? What happened when the base was negative? Yeah, do you remember what that's called? Begins with an O. That's okay. It's oscillating. It goes positive, negative, it just won't work. So the base cannot be negative. Okay, but as long as you just know the base can't be negative, then you're good. There's two special ones. The common base is 10. And so if you just see something like log of x, that means it's log base 10 of x. So if the base isn't written in there, then it's understood to be a 10. And that's because we have a base 10 number system. Like we have 10 digits. We have 1 through 9 and then 0. So we have a base 10, like our numbers cycle every 10. So base 10 is the common base. So if there's nothing written, it's understood to be 10. And then the natural base is E. Does anyone remember about what E is? It's a decimal, it's a number. 2.718, all right? As long as you know it's about 2.7, you're good. As long as you know it's a number, honestly, I'm happy. It's not a variable, it's a number. The way that that is written is ln of x. That means log base E of x. You're never gonna see this though, it's written ln and it's called the natural logarithm. It's like ln though, like log natural. Natural logarithm is ln, so that means the base is E. So we're just going to practice getting used to what a logarithm looks like. So all of these say write in logarithmic form. That means the first thing you're going to write is the word log. If it says write in logarithmic form, the first thing you're going to write is the word log. And then this is uncomfortable for a lot of people because they're like, get this word out of my math problem. I understand it's uncomfortable at first. You'll get used to it, okay? Write the word log, and then you just have to get all the puzzle pieces in the right place. First, do the base. That is the little subscript. It's stupid, but sometimes I'll say the base goes in the basement, like it's the little subscript number. When you look at 2 cubed equals 8, what is the base number? 2, right? It wasn't a trick question. 2 is the base. So log base 2, leave a little gap here and put an equal sign. You want it to equal the exponent. You want it to equal the exponent. That's the whole point of what a logarithm is that you can make it equal the exponent to get the exponent by itself. So what is the exponent out of this situation? 3. So this is the base. It should equal the exponent. And so there's only one other space for the 8 to go in. This is red. Log base 2 of 8 equals 3. And again, we're just practicing getting everything in the correct format so you can get used to what it looks like. So let's try another one. Ooh, why is this a fraction? For negative exponent flips it, good. Write the word log. What is the base? 4, good. Leave a little gap. It should equal the exponent. That's the whole point. So what's the exponent? -2 And so the 1/16 goes in that blank spot. It's log base 4 of 1/16 equals -2 is how you would say that. But I'm not gonna like yank you out in the hallway and make you take like a verbal exam, so don't worry about it, but that's how you would say it. All right, anyone want to give this one a shot? It would be log base what? 36, good. Leave a little gap. It should equal 1/2. And so 6 goes in that blank. Or for this next one, the base is e. So instead of log, you're going to write ln. That's log base e. Leave a little gap. It should equal the exponent, which is what? 4, good. And so that 54.598 goes in the blank. So ln of 54.598 equals 4. And then this last one, what's the base? 10. If you write log and then a base 10, fine, but you don't have to. When it's base 10, you just don't have to write anything. It's just log, leave a little gap. It's going to equal what? 3. And so 1,000 goes in the blank there. The 10s are easy because we have a base 10 number system. When it's 10 to the third, you have 3 zeros. You following me there? Like 10 to the 7th would be a 1 with 7 zeros. Like you can just count the zeros and that tells you what the exponent is going to be. Now we're going to practice doing that backwards, right? These in exponential form. Number 6. Oh, it's not written. What's the base? 10. What's the exponent? The logarithm should equal the exponent. So whatever it equals is your exponent. 2 equals 100. Then you can check, does that make sense? Is 10 squared actually equal to 100? Like if you wrote 100 squared equals 10, would you go, hey, that's wrong? Like common sense, right? How about this one? Good, 5 squared equals 25, which is true. This one would be 49 to the 1/2 equals 7. To the 1/2 means what? What does to the 1/2 power mean? Or not divide by 2, but square root. To the 1/3 would be a cube root, but square root of 49 gives you 7. All right, oh, what's the base for this one? E. It's e to the power 1.945 equals 7. Oh, wait, I did that backwards. I'm so sorry. No, wait, no, I didn't. 1.945, sorry, the decimal threw me off. The logarithm equals the exponent, so 1.945 is your exponent. All right, and then the last one, what is the base? 2, and then it's to the power -3 equals 1/8. It's reciprocated because of the negative exponent. Is this all sitting well with everybody? It does take some adjustment though. Like I get that the word log throws people off, so you do have to get used to it. All right, I'm gonna review the exponent properties just real quick. When you are multiplying, you would add your exponents, and this just froze, so hold on one second. So whenever you're multiplying, you add your exponents. I'm just gonna make up a little example. Give me some smallish numbers. We'll just make up an example for each of these. All right, we'll have x to the 3rd times x to the 2nd. When you're multiplying, you add your exponents. 3 plus 2 is 5. It will give you x to the 5th. Go ahead and put the phones away. This is going to be a short lesson. You can stay with me. Multiply means you add your exponents. Dividing means that you subtract your exponents. So for example, if you had x to the 8th divided by x to the 2nd, what would that give you? Good. 8 minus 2 is 6. Are you all really that tired? Okay. When you do a power to a power, you multiply them. So for example, if you had x to the 3rd to the 4th, like a power to another power, that would be x to the 12th. You would multiply them. And then here's your negative exponents. We went over this last time, but I'm just going to review a couple. I'll make up a couple examples. 5 to the -2. What would that give us? 1/25, good. How about 3 to the -3rd? 1 over, good, 3 cubed is 27. How about 2 to the negative 4th? Good. 2 to the 4th is 16, you flip it over. Okay. All right, and then the fraction exponents. To the 1/2 would be a square root. To the 1/3 would be a cube root. So say you had 16 to the 1/2. What's that going to give you? That'd be 4. Good. How about 125 to the 1/3? 5. All right, and then I kind of covered that too. Oh, and then just, I didn't put it on here, but anything to the 0 power would give you what? 1. Anything to the 0 power is 1. This is a review. We looked at that last time, but just reviewing it again. You have to get that in order to do anything else that we're doing. So evaluate. All right, this is the bread and butter of this lesson, which you got to be able to be good at doing. You are looking for the exponent. Remember, the logarithm should equal the exponent. So what this is saying, and I'm going to write it out, but you want to get the hang of being able to do this without having to write anything. Like, you want to just be able to answer the question. The base is 2. We're looking for the exponent, and then it should equal 64. So this is asking 2 to what power will give you 64? Let's count on our fingers. That's why we've got them. All right, what's 2 to the 1st? 2 squared, 4, 8, 16, 32, 64. So 2 to the 6 will give you 64. So that answer is 6. You're looking for the exponent. So what this next one is asking you is 81 to what power is going to give you 9? How do you get from 81 to 9? What do you need to do? It's a square root. So what power means square root? 1/2. This next one, I know it's going to be negative. How do I know it's going to be negative? It's flipped. It's reciprocated. All right, so it's going to be negative what? -3. Good. If that's what you said, I'm sorry, I just couldn't hear you back there. -3. It's negative because it's flipped over. 3 cubed is 27. Oh, what's the base for this one? 10. You can just count the zeros. It's 10 to what power gives you 10,000, but it's just the number of zeros. So how many zeros do you see? 4. That's an easy one. Just count up the zeros. How about this one? It's 17 to what power gives you 17? Yeah, anything to the 1st is going to be itself. Or the other way you can think of that is these canceling out and you just get 1. And then how about this one? It's 12 to what power gives you 1? 0. So anytime you see a 1 there, it's going to be 0 because anything to the 0 power gives you 1. It doesn't even matter what the base is. And then for 17, you have ln, that's base e, and then e to the 9th. The ln and the e cancel each other out. They're inverses, so they undo one another, and you just get 9. What would be ln of e to the 3rd? 3. ln of e to the 7th? What's that? Because they are inverse functions. So they undo each other, and then you just end up with whatever's there, which is kind of nice. And let me, you guys are all really tired, but that was a good question. Give me a number, any number. Let's do log base 4 of 4 to the, give me another number, 2nd. The log base 4 and the exponential base 4 cancel, and you would just get 2. It's the same idea. So anytime the base is the same, they cancel out and you just get whatever's there, which is nice. All right, now this is typically how you see these, but on Delta Math, they sometimes put the variable in a different spot, and this froze again. Hold on 1 second. So I'm just going to make up another couple of these and show you what it would look like if you put the variable somewhere else, because this is typically how you see it, but Delta Math does it a little bit differently sometimes. So say you had the x here instead. Log base x of 25 equals 2. That's x to the 2nd equals 25. You'd have x to the second equals 25. So what would x have to be? 5, okay? Just sometimes they put the variable somewhere else. Or they could put the variable here. So this would be 2, oh my gosh, froze again. So this would be 2 to the 4th equals x. So what would x be? 2 to the 4th would give you 16. All right, so if they stick the variable somewhere else, it's still the same thing, okay? And the last thing we're gonna do, and hopefully I can get through this before my projector gives out on me, is finding the inverse, all right? If it is exponential, the inverse is gonna be a logarithm. If it is logarithmic, the inverse is gonna be exponential. Are you following me? So when you see this, and this is exponential, your answer should have the word log in it. And see how this is logarithmic? Your answer should be exponential, okay? You will get stuck. Whenever I say that, everybody's like, no, not me, I'm really smart, I'm not gonna get stuck. No, the point of these problems is you will get to a step where you're stuck. And when you get stuck, not if, when you get stuck, the question that will get you unstuck is, what is the base? What is the base number? If you ask yourself, what's the base, that will help you get unstuck. I used to tell people to think about that Meghan Trainor song, but like the more years that go by, like now it's an old song and no one knows what I'm talking about. But do you know that song that Meghan Trainor, you know, I'm all about that base. Anyway, just think about that and that'll help you get unstuck. How do you find an inverse? This is what we did on the last unit, so I'm hoping you're all with me. Put away the stuff for the other classes and the phones and all of that. We're paying attention to this now. How do you find an inverse? Switch x and y, perfect. So scribble out f of x, call it y. We're gonna switch x and y. So this will be x equals 1/2 to the y power plus 1. And now your goal is to get y by itself. So what are we gonna do to both sides to start solving that? Subtract 1. And now you're stuck, which is fine. What is the question that gets you unstuck? What is the base number here? Is 1/2. So it is going to be log base 1/2, leave a little space. It should equal the exponent. It should equal the exponent. What's the exponent? Y. And then what did we not use yet? That's what goes in the little blank. Yeah, and I would give that a hug, that x minus 1, just give that a hug. That's your answer. I'm going to erase the y. Since we found an inverse, what should I put instead of y? Yeah, with the little -1 in there, that's your inverse notation. Let's try it again. Scribble out f of x, call it y. We're going to switch x and y. Oh, foreshadowing. This one has an e in it. So what's going to be in your answer? What's your inverse for e? The answer is going to have an ln in it, just as a heads up, right? Switch x and y. X equals 2e to the y minus 7. And then you start solving that. What would you do to both sides? Yeah, add 7. So we like solving. That's like a familiar territory to us. All right, and then divide by 2. And then you're stuck, which is fine. Everybody's always like, no, I'm not going to get stuck. You are. That's like the point of the problem. To get unstuck, what is the base? The base is e. And so this will be ln, leave a blank. It should equal the exponent. So what's the exponent? Y. And that's the whole point, is you want to get y by itself. Now I'm going to write inverse instead of y. If you write y, that's fine. And then this x plus 7 over 2 is what goes in the blank. So it's ln of x plus 7 over 2 equals our inverse. Now 20 and 21, these are logarithmic. So your answer should be exponential. Now the question I usually get on this, is it log base 4 of x or is it log base 4 of x plus 3? It's just the x. If it was the x plus 3, you would see parentheses around that. Does that make sense? Like if there's no parentheses, it's just the x part, right? So scribble out f of x, call it y. We're going to switch x and y. So x equals log base 4 of y, and then a plus 3. And then we're going to solve that. What do you do to both sides? Subtract 3. I'm stuck. How do I get unstuck? What's the question? What is the base number there, guys? 4. It is 4 to the power x minus 3 equals y. And I'm going to write inverse instead of y. So it's 4 to the power x minus 3 equals y, and that's your inverse. All right, one more. Scribble out f of x, call it y. Do you see how there's parentheses around the x plus 8? That's what I was talking about. It's ln of that entire thing. So we'll have x equals ln of y plus 8 plus 2. Subtract 2. And then I'm stuck. What is the base number for ln? E, good. It is going to be e to what power? Good. E to the power x minus 2 equals y plus 8. And then your last step is to subtract the 8. You cannot combine the minus 2 and the minus 8. This is inside of the exponent, and that's why I gave it a hug to kind of keep those separated. And again, I'm going to write inverse instead of y. If you write y, fine, but technically it's an inverse. So if you see ln in the problem, you know e is going to be in your answer. They're inverses of each other. That was like the whole point of the lesson. We got that?